Welcome everyone to Beyond Earth. Ever wonder what it was really like the day the dinosaurs died? Not just a big rock hit, but the first few minutes of that planet-changing catastrophe? You know the basics. A giant space rock slammed into Earth millions of years ago and poof, no more T-Rex. But thanks to incredible new technology, scientists have painted a fresh, terrifyingly detailed picture of those first moments. And guess what? They even think they know where this colossal asteroid came from. So here's a question to start us off. Could Earth be in the crosshairs for another cosmic giant? And if so, would we even stand a chance? What NASA astronomers have recently uncovered might just surprise you, and honestly, it's a bit shocking. Alright, buckle up. Let's journey back 65 million years and experience the disaster that nearly snuffed out all life on our planet. The main event: a massive asteroid hitting the shallow waters of what we now call the Gulf of Mexico. That alone was devastating. But hold on, it didn't stop there. What followed was a terrifying cascade of disasters. Rocks raining from the sky like fiery hail, continent-spanning wildfires, and colossal tsunamis flooding coastlines thousands of miles away. Researchers, by studying layers of rock from the Chicxulub crater, that's the giant dent the asteroid left, have pieced together a new minute-by-minute record of this day of pure chaos. They published their findings in the Proceedings of the National Academy of Sciences, using everything from high-res photos to CT scans of the ancient rock. And it all began something like this. Imagine you're somewhere in North America 65 million years ago. Dinosaurs are roaming, and you glance up at the night sky. You'd probably spot what looks like a bright, distant star. But if you watch this peculiar light for an hour or two, you'd notice something odd. It would seem to grow brighter, yet barely move. What you'd be witnessing isn't a star at all. It's a colossal asteroid somewhere between 11 to 80 kilometers wide. That's roughly 7 to 50 miles across, on a direct collision course with Earth, screaming in at 72,420 kilometers per hour, or 45,000 miles per hour. Can you even imagine seeing that? Hours later, this mountain-sized monster plows through Earth's atmosphere, heading straight for today's Yucatan Peninsula. Now, when space rocks hit our atmosphere at such speeds, the air itself acts almost like water. Smaller ones, meteors, are like pebbles tossed into a pond. They slow down fast at high altitudes, burning up from friction. Some bigger bits might survive and fall. But the Chicxulub asteroid? This was like throwing a boulder into a puddle. It barely slowed, plunging through the entire 60 miles of atmosphere in just 3 seconds. As it shrieked over Central America, it would have unleashed the mother of all sonic booms, shattering eardrums across continents. What do you think the dinosaurs felt? They were likely terrified, scattering in every direction, with absolutely no clue what was about to hit them. If any animal was close enough to see the asteroid hurtling down, they would have been vaporized almost instantly. In fact, apart from sea turtles and crocodiles, no four-legged animal larger than 25 kilograms, about the size of a medium dog, would survive this. This space rock fell so incredibly fast that the air beneath it couldn't escape. Under that intense compression, the air heated to thousands of degrees in a blink. Even before the asteroid physically hit the ground, this superheated, compressed air vaporized much of the shallow sea covering the Yucatan. Milliseconds later, the rock slammed through what little water was left and smashed into the bedrock. In that single horrifying moment, a devastating chain reaction began. The asteroid hit with so much pressure that solid earth and rock started to flow like liquid. Picture someone doing a cannonball in a pool. That double splash? The initial splash outward, followed by a delayed vertical splash as the water rushes back in? The Earth did something similar. The first wall of Earth, gouged out at the moment of impact, was more than 32 kilometers or 20 miles high. The impact hole it created nearly punched through to Earth's mantle. And when that cavity rebounded, forming that delayed vertical splash, The Earth itself surged upwards at over 1,600 kilometers per hour, 1,000 miles per hour, creating a temporary mountain taller than Mount Everest. Within minutes, this mountain of debris almost entirely collapsed in a series of secondary explosions, leaving behind a smaller mound we call a crater's peak ring. At the very same instant the asteroid struck the Yucatan, it converted the kinetic energy, the energy of motion of a 7.5 billion-ton rock traveling at 16 kilometers per second, 10 miles per second, into searing, unimaginable heat. The Chicxulub impactor delivered about 1 septillion 300 sextillion kilojoules of energy. That's a 13 followed by 23 zeros. To put it in perspective, that's more energy than 1 billion Hiroshima atomic bombs. Can you even comprehend that scale? This energy transferred to the soil, rock, and air, heated molecules to temperatures far hotter than the surface of the sun. This intense heat ripped electrons from atoms, ionizing the air into an expanding fireball of plasma, supercharged with vaporized rock, exceeding 10,000 degrees, and blasting out at hypersonic speeds. The heated, rapidly expanding air and the near-instant conversion of Earth to gas, combined with the impact shockwave itself, formed a massive blast wave of pressure expanding outward at more than 1,600 kilometers per hour, 1,000 miles per hour. If this asteroid hit the same spot today, that blast wave would vaporize you if you were in Texas, deafen you in New York, and blow out glass windows all the way down in Buenos Aires. The Chicxulub impactor literally rang Earth like a bell. Waves in Earth's crust radiated away from the impact zone at 4 kilometers per second, 2.5 miles per second. What do you think these crustal waves did? They triggered massive, fault-slipping earthquakes across all the continents. If you were on the opposite side of the world, you would have felt the ground shaking violently about 30 minutes after impact. And the water? The impact triggered tsunamis as high as skyscrapers. The first of these monster waves hit Gulf coastlines within the hour. Waves ranging from 600 feet to perhaps as tall as 1,000 feet smashed into what is now Mexico and the southern United States, flooding tens of miles inland. These waves even temporarily reversed the flow of rivers, rushing up riverbeds like 30-foot tidal bores. Tsunamis slammed into the eastern coast of the United States, and 6 hours after impact, they maxed out as 600-foot high walls of water hitting Europe, Africa, and the Mediterranean coasts. Within 15 hours, these devastating waves had reached every coastline on the planet. Depending on the local landscape, the ocean swept away everything in its path, and then sucked it all back out to sea when the waters finally retreated. Sounds like Armageddon, right? But believe it or not, even more disasters were on their way. When that big rock struck, its splash accounted for 25 trillion tons of Earth launched on ballistic trajectories, basically shot up into the sky. Some at speeds so fast they actually exceeded Earth's escape velocity. Some of these rocks left Earth's gravitational pull entirely, perhaps ending up orbiting the Sun, and some material likely even reached the Moon. But the vast majority of this ejected debris rained back down on Earth within the hour. These were glass-like chunks called tektites, some as large as buses, but most the size of marbles. Imagine a global hailstorm of these, pelting the Earth at speeds ranging from 160 to 320 kilometers per hour, 100 to 200 miles per hour, in lethal quantities. No matter where any remaining dinosaurs were on Earth, they were hit with this fiery barrage. But these glass bullets didn't even need to hit the dinosaurs to be fatal. As these tektites fell, the friction they created with the atmosphere emitted so much thermal radiation that it literally set fires across the entire planet. By some estimates, the combined heat of these returning embers heated the planet to the equivalent of an oven set to broil. Most of the world's trees burned. Think about that for a second. Why do you think the only bird species that survived the impact were those that nested on the ground? Of the few larger land animals to avoid extinction, nearly all had some way to escape that intense heat. They could either burrow like small mammals, snakes, and lizards, or escape into water, like crocodiles or turtles. Even if the poor dinosaurs were on the other side of the world, they would have needed to find shelter from that initial searing heat blast. And in a final piece of terrible luck for the dinosaurs, the Chicxulub asteroid just happened to strike an area rich in oil and sulfur. The impact ejected 100 billion tons of vaporized sulfur and 30,000 quadrillion gallons of water into the atmosphere. What happens when sulfur and water mix up there? They condensed into massive storm clouds and fell back as torrents of acid rain, which acidified the oceans. In the higher latitudes, continent-wide snowstorms deposited tens of feet of snow per day. But this global deluge didn't last long. Why? Because in addition to water, Chicxulub vaporized and explosively ejected the equivalent of 150 football stadiums worth of oil from the Yucatan bedrock. This oil condensed in the stratosphere as a black, sooty layer, covering the Earth like a coat of black paint. Unlike the sulfur and wildfire smoke, this carbon circulated high above the cloud layer, stopping it from raining back down. And that became another massive problem. This soot layer remained in the atmosphere, reducing the amount of sunlight reaching Earth's surface by a staggering 90% for at least 2 to 3 years. So the initial oven-like heat from the returning tektites was followed by a deep, long-lasting freeze. Global temperatures plummeted by an average of almost 50 degrees Fahrenheit, around 28 degrees Celsius. The only places on Earth to avoid this deep freeze were areas like Madagascar, India, and Indonesia, which were tropical islands at the time. In this global chill, evaporation almost ceased, dropping rainfall by 80%. Nearly every spot on Earth outside of these tropical islands dried into a desert. Phew, what an ordeal! So where did this giant rock even come from? And the million-dollar question: is there another one out there with our name on it? Researchers using a supercomputer studied asteroid evolution, looking at data from known asteroids. A team, Avi Loeb and Amir Siraj, suggested that the Chicxulub asteroid likely originated from the Oort cloud, a vast sphere of icy debris at the very edge of our solar system. It could have been a much larger comet that got nudged off course by Jupiter's immense gravitational field, sending it close to the Sun where it broke into several pieces. These fragments can cross Earth's orbit and hit our planet roughly once every 250 to 730 million years. Judging from this study, it's not a matter of if we could be hit by another giant rock from outer space, but when. Chilling, isn't it? In fact, on Saturday, December 11, 2021, NASA revealed that a 330-meter-long asteroid named 4660 Nereus screamed past Earth at a distance of about 3.8 million kilometers, 2.4 million miles, traveling at 6.5 kilometers per second, that's over 14,700 miles per hour. While that might sound far, any slight deviation in its orbit could put it on a direct course with us in the future. Astronomers are tracking this potentially hazardous rock and say it will come within 1.1 million kilometers, 745,000 miles, of Earth on Valentine's Day in 2060. So, maybe buy your flowers and get those proposals done early just in case. Keep in mind, the asteroid that caused the Chelyabinsk explosion in Russia back in 2013 was just 20 meters in size. The scary part? We don't currently have a known, reliable way to defend Earth from a truly giant space rock. However, there's hope. NASA's DART mission, which stands for Double Asteroid Redirection Test, aimed to see if a spacecraft could autonomously navigate to a target asteroid and intentionally collide with it. The idea is that this kinetic impact, a fancy term for a big smash, could push the asteroid off a collision course with Earth. DART's target was Dimorphos, a small asteroid moonlet orbiting a larger asteroid named Didymos. The spacecraft successfully impacted Dimorphos in late September 2022, when the system was about 11 million kilometers, 7 million miles, from Earth. While successful in altering its orbit, it's estimated the collision changed the speed of the moonlet by just a fraction of 1%, stopping a 10-kilometer wide or bigger asteroid hurtling towards us at over 72,000 kilometers per second will take a lot more than a small spacecraft bumping into it. Perhaps, like in the movie Armageddon, the world would need to consider more explosive options. What do you think? Maybe you have an idea how we could stop a world-ending asteroid. You could become famous. Let us know your thoughts in the comments below. And make sure to stay tuned here for more exciting stuff happening in our universe. Thanks for watching. And hey, congratulations to all of us. Our Beyond Earth channel has reached over 1 million subscribers. We truly thank you, our friends, and we are so happy to keep making these videos for you. Thanks again. Don't forget to hit that subscribe button and ring the bell so you don't miss our next cosmic adventure. See you in the next video.